Oops. Okay. So last time we have its generalized coordinates, no? Generalized coordinates. So we have an example of three particles in space. If I have three particles in space, I have 9 degrees of freedom. But if i-connect mo tong tulo, ma-reduce siya into 6 na lang, no? 6 ka degrees of freedom. Okay? Okay, so another example is what if we have this, share sana akong screen. So what if I have a particle constrained to move along the surface of the sphere? Question is, how many degrees of freedom are there? So nako isa ka particle, no? Nako isa ka particle. Sige daw, tabangin ako. Unsa or pila ka buk degrees of freedom ang naa sa kani nga system, and unsa ang mga independent variables ang imo i-consider. Okay, say kita niya akong screen, no? Okay, right. Okay. So, for example, this one. Kabangin ako, iha pila ka buk degrees of freedom gamit ako. So, example, I have particle, a particle, isa lang kabuok, no? A particle constrained to move along the surface of the sphere. Question, pila ka buok number of degrees of freedom ani? Si Juliana, di na to pansiron si Juliana kaya nag-answer naman siya last time, no? Kabalo lang si Juliana ani pila ka buok. Sige, anyone? Or si Juliana rin po na itong pansiron? Hello, Juliana, napaka dira Juliana, no? So I have
Buhay ko, sir.
wait pa ka, sorry. I have a particle, which is constrained in along the surface of a sphere with some radius r. Okay, sphere siya, no? Dili siya plane polar, no? Dili siya two-dimensional nga motion lang, but ako'y bola, say, mura siya og planet Earth, and then the mass, the particle will be u. Okay, so naman ta sa surface, right? Ako'y planet Earth, and then naglakaw-lakaw ka at the surface of the planet Earth. Question is, how many degrees of freedom ang naa sa imuha? Ang nasa particle, ang nasa imong system. Pila ka po? It
5,
has
sir, 5.
5? Anong 5 man? Ikaw rin may isa, no? Isa lang man ka particle, tama ba? Isa lang man ka mass, okay? Isa lang ka mass. Isa lang ka mass. Pila ka book degrees of freedom?
3?
Pila? Pila to?
Sir, sir, 3.
3. 3 siya. Originally it's 3, no? Because it's in 3 dimensions. Ako? But take note, naka-constrain siya to move along the surface of the sphere. So, meaning na siya isa ka equation of constraint. Tama ba? So, therefore, 3 siya originally, but minusan mo isa for isa ka, minusan mo isa for the constraints. Okay? So, 3 minus 2, it only has 2 degrees of freedom. Okay? Nalang ko duha ka degrees of freedom lang. So, meaning sa 2 degrees of freedom, meaning I also have 2 napukoy duha ka generalized coordinates. Okay? Napukoy duha ra pud ka generalized coordinates. Unsa ako ang force of constraint, equation of constraint ani? Sige daw, unsa nga equation akong equation of constraint nga makuha ani nga system? Nakoy Sabangay ako ninyo, eh. Kaya di ko kabaluan yun. Unsa akong equation of constraint ani nga system? Jessa. Kabalo ka, Jessa?
Katong kuan, sir.
At the surface, no? Along the surface, ang motion sa imong mass, sa imong particle. So, I have 3 originally, but I have 1 equation of constraint. And question is, what is that equation of constraint ang nasa imong sa ato ang system? Nakoy katong equation sa imuhang equation sa ako ang force uh, yeah yeah, thank you, Joven, pero it's not a a force. In this case, it's not a force of constraints, but it's an equation of, take note, fix man ihang r, sakto? I-fix man imong r, sakto? So, meaning, ang imong equation of constraint ani is the equation of the radius r, sakto? So, and take note, in 3 dimension, the equation for our radius r is just equal to this. R square is equal to, kani, x square plus y square plus z square. Sakto ba? Uh, the radius of this sphere is actually, in terms of Cartesian, it's actually equal to this one. So, usually, ang force of constraint is gina-equate niya into zero. That's why, usually, ang iyang form is this. You have to, um, you have to uh, transpose this such that you will have to equate it to zero. So, ang formal nga pagsulat sa equation of constraint is ingani sa form. Okay? So, ingani sa form, dapat equate mo siya into zero. Say, for example, if I have r equal to square root of x squared plus y squared, then you have to write it in terms of this one. X squared plus y squared equal to zero. So, dapat equate mo siya, i-transpose mo tanang variable sa imong right side para mahimo siya zero sa pikas nga equation. So, this is my equation of constraint in this system. Okay. So, there are 2 degrees of freedom. It means na napo ko'y 2 independent coordinates. Question is, unsa ako ang duha ka independent coordinates ani? Duha ka independent coordinates. Na ko'y duha lang, no? It's either xy or xz or yz. Okay? Because when you have x and y, you can solve for z using this equation of constraint. Okay? If you have um, yz as your independent variable or independent coordinates, then x can be solved from this equation of constraints. Okay? and and so on. No? If I have xz nga independent variable or independent coordinates, napo ko y nga dependent variable, and I can solve that one using this force of equation of constraints. Okay, so I have take note, 2 degrees of freedom, two generalized coordinates, or generalized coordinates means two independent coordinates. So these coordinates, two independent coordinates, are needed to specify completely the position of our particle in our system. Okay, so this coordinate could be taken as say kung sa Earth pa ni siya, no? Kung sa Earth pa ni siya, na ako is spherical Earth, and then you are the mass or you are the particle. Ang imong motion lang, it's either longitudinal nga motion or latitudinal nga motion. So it's either pa longitude ang imong motion kani sa kung Earth atong basihan, no? Na ako latitude nga motion, and then ako longitude. So I have two independent coordinates in my system. Okay? So the longitudinal nga motion and then the latitudinal nga motion. Two independent coordinates. Okay? Now, we talk about equation of constraints, and there are two types of constraints ang naa. Okay, there are two types of constraints. We call this one as holonomic and non-holonomic constraints. So unsay kalayan sa duha, dali lang, no? If it is equality, then that's a holonomic constraints. If it is an inequality, say greater than or equal or less than or equal, then we call that one as non-holonomic constraints. Okay, so before that, we know how to how to determine number of degrees of freedom. Okay, isulat lang yapon ako, no? In general, before ta maghisgot og katong types of constraints, we have this to determine the number of degrees of freedom. If I have n particles, okay, pwede mo maglibog, no? Pag ihap sa number of degrees of freedom are free ups. If I have n particles if n particles are free to move in 3 dimension. To move in 3 dimension. Okay. Then, but connected by m conditions. By m conditions of constraints. Okay. Or equation of constraints. Okay. Conditions of constraints. Then there exists. So, kabalo na tani, no? I think kabalo na tani. There exists n, which is equal to 3n minus m, where n is the independent generalized coordinates. Okay. 3 minus, this is 3n minus m. This n is called independent coordinates, independent generalized coordinates, independent generalized coordinates, or basically this is just the number of freedom. Okay. N nga gamay is just the number of degrees of freedom. Okay. So, degrees of freedom. I think kabalo dali, no? If I have two particles, I have originally 6 degrees of freedom minus equation of constraint, pila ka ba constraint ang nasa imong system, then that will be your final degrees or final independent generalized coordinates. So, the equation is very simple. It's just equal to 3n minus m. I think in statistical mechanics, magamit po ni mo ning kung kadumdum mo sa katong thermodynamics na to, no, last time, nga if I have a particle and then you increase the temperature, what will happen is there exists a you add number of degrees of freedom. Sakto kung ang imong molecule or atom kayo naglihok lang in 3 dimension, okay, naglihok lang in 3 dimension, pag painiton nimo sa to na ako'y translation na lang ang motion, translation na lang ang motion ang imong molecule. Pag increase nimong temperature, what will happen is dungagan nimo og number of degrees of freedom na sa rotational motion nga part, and then increase pag mo further, ang mahitabo kay mo stretch na ang imong molecule. Okay, so ingana, no, maadan og pila ka buok degrees of freedom, pila ka buok independent coordinates ang nasa imong system. So ingani lang gihapon, no, naragat po ingani. Okay. So, independent generalized coordinates sufficient to describe basically ang pinakauna na tukuhaon is the position of the particle at any given time t in your system. Okay? So, ma-describe nimo ang position, okay, ma-describe na to ang position depende kung pila ka buok number of degrees of freedom or independent generalized coordinates ang nasa imong system. Okay? So, yeah. So this is the equation for the degrees of freedom. Okay. Next is we have the types of constraints. The types of constraints. As I said, there are two, no? Na ako'y duha ka klaseng constraints. First is the holonomic constraints, and the second one is non-holo holonomic holonomic constraints. So sa kalayan, dali lang pinakasayon na explanation is equal ang equation sa imong holonomic, while non-holonomic kay inequalities ang imong gamiton. It's either greater than or equal or less than or equal to ang imong makuha nga types of ang equation of constraints. So for holonomic, unsa ito? Holonomic constraints are equalities. So kani di ay kani atong nakuha nga equation, kani siya is a holonomic constraints. Okay? This is a holonomic constraints. Ngano gali kay ang equation is it is equalities. Holonomic constraints. Equal imong gigamit, okay? So equalities, okay? Integrable in form, and may or may not be explicitly time dependent. May or may not be posible siya, pwede siya time dependent, pwede po siya time independent nga function. Explicitly time dependent. Okay? time dependent. So, ang form niya, matawag kayong ganyan, no? Ang form niya is dapat ingani, no? Na ako'y a function, J, for example, position xi, yi, zi, and then, pwede po siya function of time t equal to 0. So, ingani ang form niya dapat. Okay? So, dapat i-transposing mo tanang variables, tanang form, tanang expression to the left side of your equation. Okay? So, it's either a function of position only, a function of x, y, z, r, theta, phi, or a function of these positions and a function of time. So, pwede siya function of time, pwede po siya dili function of time. So, usually, ginasulat kasagara kay ingani pagkasulat, no? Na ako'y semicolon gi-separate niya ang position nga space and time, no? Position, gi-separate niya ang position and time. So usually kasagara makikita ka gingani like sa Feynman integral ginasulat siya as x x dot tapos comma time, okay? So nakoy comma time murag i-separate niya ang it's just a notation, no? It's just a notation. Pero nasa meaning nakalimutan ko sa meaning ani. Nanong gibutangan ng semicolon murag i-separate niya ang function of time. But it's just a notation, take note. Pwede po siya napoy ba nga mogamit og kaning vertical line. Okay? Anyways, it's just a notation. So nakoy position x y z and time t. So ingani mo pagsulat later if mag-solve na tag Lagrange multiplier, we solve Lagrange multiplier, dapat isulat na to ang equation of constraint equal to this one. Tanang form, tanang variable, ibutan mo sa left side sa mga equation, equate mo to 0. So, i-transpose lang nimo, no? So, xi, ji, where I is from 1 to n number of particles, while j is from 1 to m ka equation of constraint. Kaning j, no, kay pila ka buok constraint. For example, j is equal to 3, meaning tulo ka equation ang imo makuha sa tulo ka equation of constraint ang nasa imong system. Where I is when you have I is equal to 3, then ako'y tulo ka particle. Okay? Take note of that. Ang I kay nag-determine pila ka buok particle ang nasa imong system, while ang J nag-determine pila ka buok constraint ang nasa atong system. Okay? So I runs from 1 to n, while J runs from 1 to m. Okay, m atong gamit, no, sa constraint. Yeah. So m magamit m sa constraint and then n sa number of particles. Okay? So that's for holonomic. For non-holonomic, it is a constraint that cannot be expressed as equation of equality. Okay? Constraints that cannot be expressed that cannot be expressed, okay, as equations of equality. So basically, inequality siya, no? Equations of equality. Also, it is not integrable. Okay? It is not integrable or that are non-integrable. Non-integrable in form. And last is cannot be used to eliminate from consideration. Cannot be used to eliminate from consideration. Cannot be used. Okay, so makita ninyo ang kalahian sa duha, no? Equation, equality ang holonomic, while non-holonomic ay not an equation. Inequality siya. Cannot be to eliminate from consideration. Okay? So, example. Say, pinaka-good nga example sa non-holonomic. One good example for holonomic is a particle constrained to remain outside the surface of the sphere. So, example of non-holonomic constraints Kaya na ako'y particle. Okay? Particle constraint to remain outside the surface of the sphere. Okay? To remain outside the surface of the sphere. Outside the surface of the sphere. Okay, so na ako is sphere, and then I have a particle here, which is, it can be at the surface or it can be outside the sphere. So, pwede siya sa dara, pwede sa dire. This is your R. Take note, this is your R. Okay, so pwede siya dira. So, pinaka-good nga example is tao gihapon, no? Tao nga nagpuyo sa Earth. Take note, ang tao kay pwede siya makadto sa space, right? Nagali nga nakadto sa moon. So, pwede siya move outside the planet Earth, at outside the surface of this, say, sphere or Earth. Pero walay taong gusto mosulod diri sa core sa planet, sakto? Tama? So, muna yung pinaka-best na example of non-holonomic constraints. Humans on Earth capable of going to the moon, but incapable of going more than a few miles underground. Okay? So, ito. So, pwede ta makadto sa moon, pero dili ta makadto sa core sa planet Earth. Okay? So, we have a particle constraints to remain outside. Okay? Outside means pwede ka sa space, outside the surface of the sphere. So, uh, if we can identify the equation of constraint here, na ako nga no? R is the radius, okay, minus the position, x squared plus y squared plus z squared must be greater than or equal to 0. Okay? So, nako nga ni, balik sa, sorry. Constraint, outside ba dapat, no? Outside, so nako nga ni equation. Oops. Minus r squared must be greater than, or positive, no? Must be greater than 0. Sakto ba? Because take note, si x squared plus y squared plus z squared is always greater than your r squared. Okay? So, dapat positive ang iyang makuha nga equation. So, nakoy inequalities. Okay? Greater than or equal. So, this equation of constraint is an example of a non-holonomic constraints. Okay? So, this is my equation of constraint. Okay ra, no? Sakto ba? So, pwede ko sa surface when x squared plus y squared plus z squared is at the surface, then this equation will be equal to 0. But pwede ko magawas sa moon, for example. So, the x squared plus y squared plus z squared there is always greater than your r squared. So, that's why makuha nimo is always a positive number. Okay? It's always a positive number. Okay? So, that's, again, holonomic equalities, non-holonomic inequalities ang form sa equation, not equation, sa form of my constraints. Okay? So, yeah. Any questions? Okay ra, no? Walay pangutana?
Kung inside lugar, sir, positive ang R, sir.
Ansa to?
Okay na,
Kung
sir.
inside, sir.
Yeah, kung inside pod non-holonomic gyapon sa Juliana, no? Kay makuha ni mga equation kay less
Pero
than
ang R, sir, positive ang R.
positive ang
Positive
R.
ng R.
Yeah, fix man ang R nimo, no? R is the
Oh.
radius of the Earth. Okay. So, for example, Earth ato ang gihisgutan, no? Fix mo ang R, which is the radius of the Earth. If gusto ka, if your particle is inside this R, then it is also a non-holonomic constraints kay balihon lang nimo ang inequality niya. Okay? So, nakoy less than or equal to 0. Kay gamay
Okay,
man
sir.
always, kung inside ka, gamay man always ang x squared plus y squared plus z squared compared to your r squared. Okay? So, therefore, less than or equal kung nakasasulod sa imong sphere. But usually, wala man, no? In reality, kung, for example, humans, na planet Earth, wala may mo adto sa pinakailalom sa earth, no? Kay makita doon nila ang kwento, no? Murag ang ingon nila hell, ito mga hisgutan na, no? But dunay mga humans nga mugawas pero wala humans nga mosulod sa earth. Pero pwede gyapon na siya, no? Example gyapon na siya sa non-holonomic constraint. Yeah, thank you, Juliana. Yes, Julius.
Sir, sa kanang harmonic oscillators, sir,
Yes.
baka ng ang coupling, sir, kay ano na siya? Constraints.
Oh, good question. Ang coupling, ah unsa kay coupling ana kay gamma x1 x2 man na, no? Dili siya pwede siya mahimo nimong constraint kay naa koy duha ka harmonic oscillator tapos naa kay gamay nga connection sa duha. That's why yeah, pwede siya ma-equation of constraint kaning Julius. Pwede siya ma-equation of constraint. So, mag-solve ka ng Lagrange multiplier. Mag-solve nimo ang Lagrange multiplier na then makuha nimo ang equation of motion dayon. Sakto, tama. Kay na ko'y harmonic oscillator, no? Tapos, mura gidungagan mata nimo na og pero nana sa daan sa imong kuan sa imong Lagrangian nana sa daan sa imong Lagrangian kuan kanang Julius na ko'y uh, harmonic, no? So kaya Lagrangian ana Julius o 1/2 m x dot square minus 1/2 k x square m omega square man gamit x square plus ba to or minus plus gamma x1 x2 man to. Oh, kulang pa ko diri na ko kulang diri. I think we have x dot 1 plus a square plus x dot 2 square minus kaninga 1/2 m gamma square x1 plus x2 ata. Kana. Oh, 1 x square din sorry. X square. Minus ata, minus. Nakalimot ko sa form niya, no? Minus x1, x2. So, kani nga term is somewhat, uh, mura siya og force of constraint sa duha ka harmonic oscillator. Yeah, sakto. So, pwede na ako sa, i-try na to solve, no? Nga, mo gamit ang Lagrange multiplier or kaning diretso na nga nga form ang akong L. Okay, so duha atong method to calculate equation of motion with force of constraint kay ngani. Let's try this one. Wala pa na ako nang na-try actually if I use Lagrange multiplier there. Sige, diretso raman pwede ra ka mo gamit og Euler Lagrange equation na to solve the equation of motion. Yeah. Okay. Any question? Okay ra Julius, no? Sakto ra ba? Sakto ra ang equation Julius. I-check lang ang mga sign. Basta na ako'y term for the
Pero,
coupling. Na ako'y sign for the coupling katong makombine nimo ang position ni harmonic oscillator 1 sa harmonic oscillator 2. X1, X2 ba to? Yeah, pwede ra. X1, X2. Yeah. Pero pwede mo to siya ma-separate actually. Ang coupling, dunay method. Na method ana. We call ito na coordinate transformation na ma-separate nimo ang duha ka harmonic oscillator using some coordinate transformation in plane polar. Okay? Sige, let's continue, no? So we are done with that. Okay. So we are done with that. So next thing to do is we will have to determine the Lagrangian. Okay? So dapat kung ako'y system kabalo ka mo solve or kabalo ka mo determine sa unsa ang Lagrangian ato nga system. So laylay nga system, laylay mag Lagrangian, no? And take note, Lagrangian is all about kinetic energies and potential energies. So once na ako'y system, automatic kuhaon nimo iyang kinetic energy and potential energy. So dunay system nga obvious iyang kinetic, obvious pud iyang potential. But doon na po'y system nga lisod kuhaon ang kinetic ug ang potential energy. So kada no, na trick or yeah, na mga system nga dili obvious ang pagkuha sa kinetic ug sa potential energy. So our next topic is we have calculating kinetic and potential energy. Why? Because important siya because Lagrangian is all about kinetic and potential energies. Okay, potential energies in terms of generalized coordinate of generalized coordinates. Take note ha, ang atong notation for generalized coordinate is not in XYZ, it's not in um, it's not in R theta phi, but it's all about Q's. Okay, Q, kung may ko Q i's, it means that this notation is for our generalized coordinates. So pag specific na dayon sa imong system, so Q can be in Cartesian, can be in spherical, can be in cylindrical. Okay, so for generalized, we have to use Q. Okay, pag specific na imong system, then mo gamit na ka Cartesian, polar, cylindrical, and so on. Okay, spherical. Okay, we have to take note, L is just equal to the kinetic minus the potential energy. So, sayon na kayo na equation, no? Kinetic minus potential energy. So our problem is how will you determine kinetic and potential energy in the system? Say for example, I have this free fall, for example. Sige daw. Sa free fall, unsa akong Lagrangian? I think nasulat na ako no? Sa free fall, what's my Lagrangian? I have an object moving to that direction. What will be my Lagrangian? Pila ka buok degrees of freedom sa free fall. Anyone. In free fall, I have mass m that is
Sir.
moving downward. Pila ka buok?
Sara sir, kay why raman?
Isa lang, no? Isa lang ako ang degrees of freedom uh, sa ako ang mass. Okay? So meaning isa ra pud ka generalized coordinate. Kasagaran na to gamit is y, sakto ba? Kasagaran na to gamit is y. So that's why your L is just equal to this. Ako 1/2 m y that square minus mgy. So this is for the Lagrangian of a free fall. Okay? So anong minus mgy? Take note, if this is your ground here, then your y is positive. Tama? So your potential here, the potential energy is just the gravitational potential energy, which is equal to mgh, or you use generalized coordinate as coordinate as y, so that's why nakoy mg times y. Okay? Pero in the book, sa book ni Fowles and Cassidy, bisag downward ug upward pa na iyang motion, kasagaran nila gamit is x. Okay? So ay lang mo kalibog, no? Ay lang mo confuse. Ikaw man mabuot unsa nga coordinate imong gamiton. But if basahon nimo ang book ni Fowles and Cassidy, usually basta mo iyon kung position, ang ginagamit nila is position x. Okay? But sa to is y man, no? But alam mo ka-confuse later, no? Usahay kay x ang gamiton nga variable nga ginagamit even though ang imong motion is upward or downward nga motion. So if x na siya, dali ra gyapon, no? X, i-change na imong variable. Okay, 1/2 mx that square minus mg times x. Okay? If this is your ground. Okay? Sometimes also, napoy uban nga, for example, atwood machine. Sa atwood machine, dito ito ta. Sa tawag ni pendulum, for example. Sa pendulum, usahay, imong gi-consider nga ground or ang origin nimo is na direct. Okay? Sa pendulum, ingani kasagaran, no? Pendulum na koy R and so on. So the potential energy here is not positive, sakto, because as you can see, this will be your x. Again, bisag downward o upward pa nga direction kay kasagara, ang ilang gamiton is x. Y na lang parte mo maglibog, no? Pero usahay lagi, no? Ay lang mo confuse sa x ug y. Okay? X ug y nga gamay, napoy x ug y nga dagko. Okay? So this is y. Okay? This is y. So as you can see, the potential energy here is if your origin is at the top, then the potential energy must be negative. Okay? mg times y. So pag sulat nimo sa Lagrangian ron, nakoy t ma-plus na din siya, no? Plus mgy. So dunay mga system nga your potential energy is positive. So Take note ha, T minus V na siya, no? So, nakoy minus minus mgy, that becomes plus mgy, okay? So, depende, no? Kung asa mo ang origin, tapos if your mass is below the origin, then your potential energy is a negative function, negative mg times 1. Okay, take note of that. So, pwede man negative yung potential, pwede po no positive. Kung ako sa taas, positive yung mgy. Kung ang imong particle is nasa ubos, minus mgy, ang imong gamiton sa imong potential. Okay? Okay. So na ako. Hindi mo mag-book. Oops. Sakto na ni. So, next. What if I have, i-complicate na ko gamay. What if I have this, for example, simple pendulum. Sige daw, bangit ako answer ani. Na ko'y pendulum attached to a movable support. Okay? Movable support. Okay. So, na ko'y, if I draw this one, na ko i-draw. Waon ako sa, diri pa rin ako mag-drawing. Oops. Dito. Chapter 10. Basta sa nito na ako ano. Isa, no? Yung isa. Simple pendulum. Ako'y duha ka particle, no? Ako'y duha ka particle. So, simple pendulum attached to a movable support. Attached to a movable support. Question, originally, pila ka buok degrees of freedom ang naa?
Duha, sir.
Pila?
Duha.
Duha, originally, duha ra ka buok? Duha ka particle, sa to? Duha ka particle, originally na ako'y 6 degrees of freedom in 3 dimension. Ang tawa? Pero, I have how many constraints here? Pila ka ba constraints na? So, nakoy duha ka particle, no? Gamay nga M, o dako nga M. Okay? And then, so I have 6, 3n is 3 times 2 is 6 degrees of freedom minus how many equation of constraints here? Pila ka buong equation of constraints ani?
Duha, sir.
Duha ka equation of constraints? Duha lang? Rona Marie?
3.
3? Juliana, unsa tong duha?
Gikan diya sa Y then padung sa dako na M then ang ikaduha na constraints kay gikan sa M na dako padung sa M na gamay.
Okay. Dili ni sa kuan Juliana, no? Sakto ka sa ani, no? Sakto ka. So, you're correct with this one. This one is fixed nga R. So, this is one equation of constraint. Okay, sakto na siya, no? This one is moving. Dili siya fixed, Juliana. Pero ma-confuse ka, no? Kay mura siya gisumpay siya sa origin, ano? But take note, this one is moving. Your M nga dako is, you call it as your movable support. This one is actually moving from there to that one. Okay? So, galihok ni imuhang mass M padulong dito. Okay? So, lantaw na ko, no? I have, in this case, in this system, I only have 2 degrees of freedom. Here. 2 degrees of freedom. Okay? Or, so, para sa naman siya, no? 2 generalized coordinates. So, nako'y duha ka generalized coordinates. So, meaning, 6 ang iyang original, no? 6 ang iyang original nga degrees of freedom. Meaning, nako'y upat ka equation of constraints. Tama? Para 6 minus 4, that will be equal to 2 number of degrees of freedom. So question is unsa ning upat ka equation of constraint? Sakto si Juliana, no? Pinakauna na constraint is this R. Okay? This R here. This R here. Kaduha, okay. I will let M kaning dako. I-let na ko ang coordinate ni M as dagko nga ang coordinate sa M is dagko nga X, Y, and Z. Ito na. Dagko ni siya, no? Capital letter X, capital letter Y, and capital letter Z. So these are the generalized coordinates of my M. Okay. Capital X, capital Y, and capital Z. Originally, without considering the constraints. Okay? Si M nga gamay, kina siya coordinate nga gamay, nga X, gamay nga Y, o gamay nga Z. Take note of this. So, unong dapat siya, no? Sakto ba? Unong dapat ang ako ang equation of constraints. Okay? So, X, Y, or Z. So, makita po nimo no, nga ang si M is moving at big letter X na position. I have 4 equation of constraints. Take note, si M nga dako, si movable support is moving along X lang. Sakto? Si M nga dako is moving along X. Meaning, makakuha kong duha ka equation of constraints dire. I have first, Y nga dako is equal to 0 and Z nga dako is also equal to 0. Tama? Sa M pa lang na ada kaning movable support M. Ano ba ito? Nakoy duha ka equation of constraints sa ako ang dako nga M because take note M is just moving along X or along X na direction. So it means na there's no Y, 0 imo Y. Dili kani nga Y nga gamay, no? Kaning Y nga gamay is for M na kaning pendulum nimo, no? There's no Y nga the big letter Y, so Y big letter Y 0 and big letter Z is also equal to 0. Another one, if plantaon nimo si M nga gamay, plantaon ako si M nga gamay, ang M nga gamay is just moving along XY plane. Sakto? XY plane nga gagmay nga letter. So therefore, the Z nga gamay, small letter Z is just equal to 0. Okay. So niyon ko upat ka po. Unsa ang isa? Katong gi-answer ni Juliana. The equation for R. So that's my last equation of constraint. Okay, ito. Y nga dako is 0, Z nga dako is 0, Z nga gamay is 0 because your pendulum M is moving only in the XY plane. Okay? And then the last is with respect to my R, which is equal to this one. Okay? X nga gamay minus X nga dako. Maklaro ba nga X nga dako niya sa? Ito na itong X. Oops. Dako na kayo. Gamay nga X minus dako nga X square plus Y square minus R square equal to 0. So these are the 4 equations of constraints. So as you can see, kanong X minus X quantity square mo na siya. Makita ba nga X minus X na siya, no? Tama ba? Your R, take note, if this is X na dako, this one is also X na gamay. Basta ba? That one is also X, No. That's not X na gamay. Ang X na gamay is this one. Okay, dire magyapon ka nag-start sa imong XY plane. Okay? Sorry, so this is my X na gamay. Okay? It's my X na gamay. Gamay nga X na siya, no? So, take note, to solve for R, this is Y. Okay? This is Y. Okay? That is Y. And then, as you can see, kana siya is just equal to X na gamay minus X na dako. Okay? So, minusan lang nimo, no? Kaning the position of mass M, the position of your mass M nga gamay is X away from this line here. Okay? Small letter X from this line here. And to solve this kining gamay nga portion sa imong triangle, the base base sa imong triangle, that one is just equal to X minus X. And using Pythagorean theorem, masolve nimo ang r square which is equal to this equation here. Sakto? So this is a right triangle man, no? Right triangle na siya. So therefore, using Pythagorean theorem, we can solve for the r square which is equal to this equation. So I have four equation of constraints na ko x, y, z, y, z, and z nga gamay are zeros, and then one last equation of constraint is um, for our equation for the rate, the r, the equation of, okay. So I have two generalized coordinates, two independent variables. Maklaro man ninyo, no? Na two independent variables na kaning with respect to x na dako and with respect to theta. Okay? Kaya ang pendulum, take note, kaya isa lang man kay ka degrees of freedom, no? That is just in terms of theta. So, galihok imong pendulum at the same time ga move siya in translational motion. So, I have two independent variables in this case. Okay? So, once makuha na nako ang mga coordinates na ko with respect to x, so ang coordinates lang, independent coordinates lang is kayong big letter x and the theta. I have um, two independent coordinates in this system. So once kabalo ko na, masolve na ko ang Lagrangian. Okay? So I have now the Lagrangian now of this system. Lagrangian, take note, is just Lagrangian That's equal to T minus V. Okay? T minus V, what's the kinetic energy here? Isa ako ang kinetic energy yan eh. Nakoy? The kinetic energy in Cartesian coordinates. Say, ako lang gamiton is Cartesian coordinates lang sa Cartesian coordinates. So, next is i-transform na to sa into polar, okay? Polar coordinates. The kinetic energy is just na lang ko duha, no? The kinetic energy of this big M plus the kinetic energy of this small m. Okay, so I have in Cartesian, kinetic energy is just 1/2 m nga dako x nga dako dot square plus 1/2 of m nga gamay times kaning gamay nga x square plus y dot square. Nako ba? Ano ba ni? Sakto no? The first term is for the kinetic energy of this movable support with mass big M, while the second term is the kinetic energy in Cartesian coordinates. Okay, in Cartesian coordinates, the kinetic energy of this small letter m in Cartesian coordinates. So, namo ko'y x ug y na, no? Nako'y velocity along y plus velocity along x. So, that's why nako'y 1/2 mx dot square. Kani nga x kay gamay ni sa, no? Kani kay dako ni sa dagat. Okay? Dahil na makalibog, no? Dako ni sa big letter x and then small letter x. As you can see, there are three. Kung lang taon nato, there are three coordinates nga itong gamiton. The big X, small x, and the y. But take note, na ako'y equation of constraint nga katong kanino. Take note na ako equation of constraints nga this one, the last equation of constraint. Once I know the x nga dako o I know the x nga gamay, makuha nimo ang y. Okay? So the y there, ang y dira is ang y or ang x. It's either dependent variables ya. So duha lang gid ang independent variable ani. It's either x na dako ug x nga gamay dependent imong y, or x na dako y and then dependent variable imong x. And you can solve for x using the last equation, the equation of constraint given by this. Okay? So alam mo galibog, no? Duha lang gid ka independent variable ani nga equation. Okay? So in Cartesian, medyo ma-confuse mo na basig tulo ka buok independent variables ang inyong makuha, but duha na siya, no? Duha lang ka independent variables, ang isa ka dependent variables. Pero if isolve na ko na siya in polar, sa polar makita ninyo nga duha lang gyud ka buok independent variables or independent coordinates ang naa sa imuhang or sa tuang system. Okay, so let's try this. Wala pa napay v. V is equal to mg times y. Okay? mg times y. Okay. Pero nganong Okay ra? So, yeah, mg times. Dapat minus mg times y na siya. Anyways, minus mg times y dapat na siya. Okay? Ang imuhang, there are two potential energies, but if our origin is here, if our ground is here, then the potential energy of big M is 0, while the potential energy of my M nga gamay is minus mgy. Okay? Kung ako yung minus mgy na siya. Ano din sa check na pa. Dapat minus yan, no? But anyways, minus is just, kung ang ato ang origin is this, kung itong origin, so, para di mo maglibog, if nasa south, below the origin, then you can set that one as minus mgy na potential. Pero in this case, I think, ang iyang y is nasa ubos. Ang y niya is nasa ubos. Pero sige lang. Okay, ato lang butang as minus mgy. Okay? Minus m. Doon ta siya, no? Pero zero man ang potential energy ni M. Okay, kaning big M, sorry. Big M, zero ang iyang potential energy. So, only, ang naalay gravitational potential energy is only the small letter m. Okay. In polar, okay, in polar, dito lang din, no? In terms of generalized coordinates, atong gisulat, x and theta. Okay, let's transform this one in polar. We have, take note, x nga gamay is just equal to big letter x plus r sine of theta. Sakto ba? Tama ba? Kung nagtaon na ko si x kanisa is just equal to big letter x plus this one is r sine of theta. Sakto? The length of this one is just r sine theta. So therefore, my x ng gamma is just equal to x plus r sine of theta. Si y is just equal to r cosine of theta. Okay? Minus r cosine. Minus r. Dapat r. Minus r cosine of theta. So dapat minus din siya. Tama na siya, no? So minus mgy na siya. Minus r sine cosine of theta. If you take the derivative of x, this is just equal to big letter x plus r is constant. So, ang i-derive lang nimo is only the theta. So, na ko r cosine theta theta dot. Sakto ba? Tama ba? R cosine, derivative of sine is cosine. Sakto? Derivative of cosine is, derivative of sine is cosine. So, therefore, na ko r cosine of theta times theta dot. Pwede na ko ibutang ng theta dot dira. Ibutang na ko ni sa dira. So, r theta dot cosine of theta. Para dito maglisod niya later, no? Basi masulod din mo ang theta dot sa cosine. Okay. So, that's the derivative of x, small letter x r theta cosine theta, while your y dot is just equal to r sine of theta dot. So, dito lang gapon ako ibutang sa okay, theta dot. Okay. Okay. Then, yeah, that's r theta dot. If we do substitution, if I substitute this one there, substitute na ako dira, dira, you will get this expression of your y. So, we have the kinetic energy is just equal to m over 2 x dot square. Wala nag-change ang x dot na dako. Pero nag-change ang ako kinetic energy of this small mass m. And it is equal to this big letter x plus r cosine r theta dot, sorry, r theta dot cosine of theta square plus r theta dot sine of theta. This is your y square. Okay? And your v is just equal to minus mg r cosine of theta. So notice, makita na to diri na it is just a function of two independent variables, two generalized coordinates, the x and the theta. Okay? Because r is constant. Fix man akong r, no? Since akong r kay fix man, so ang variable lang ani, independent variable lang ani is only the big letter x and the theta. Okay? So na ko two independent variables lang. So such that my Lagrangian is just for this example, Lagrangian is just binomial continuity of potential energy. P minus P minus. Okay. Okay, so mo ni x dot na to, no? Kani x dot na to na kani is y dot na. Okay? So yeah, so we are now ready to solve equation equation of motion using Lagrangian. Okay, using Lagrangian mechanics. Okay? So mo to, no? First, having degrees of freedom, pila ka buk independent variables, pila ka buk dependent variables sa nasa system. Next, identify what is the kinetic energy. So kung tulo ka buok ang imong mass, so tulo pud ka kinetic energy. Kinetic energy sa mass 1, kinetic energy sa mass 2, kinetic energy sa mass 3. And napo kay tulo ka potential. Potential energy sa mass 1, mass 2, and mass 3. Okay? So determine kinetic energy, determine potential energy, and so on. So dapat kabalo ta mo determine o kinetic potential. Say Atwood machine. Say for example, Atwood machine, no? Atwood. Let's try this one later na, no? Time na po. Time na. Okay. Sige lang. Let's continue this one. By the way, next meeting, mag-quiz ta, no? Mag-quiz ta, midterm naman next week. So, ang ato ang schedule sa midterm, kahimo na itong second long quiz. And then, ang midterm will be next week. Okay?